welcome everybody. My name is Robert Douglas, and I am the Chief DevRel Officer for Platform.sh. It's my job to talk to developers and explain the exciting advantages and benefits that they gain when using Platform.sh to deploy things to the cloud. Today's webinar is really it's entitled How to Deploy Applications with Just a Few Lines of Code Without Using Kubernetes. And I will specifically talk about exactly that. But the overarching topic of today's presentation is really about DevOps itself and some of the iterations of DevOps that we're seeing, such as GitOps, which I'll explain a little bit more, where you deploy whole applications and infrastructure simply by using git push. But to start that out, we need to establish what the goals of DevOps are. DevOps stands for, of course, developer operations. And in general, the two primary goals that DevOps achieves are to let application developers focus on writing great application code and to let operations engineers enable secure, scalable, and robust deployments and operation of those applications so that those two groups of people can focus on what they're good at without having to cross over into each other's domains too much. I'll add here that what we are particularly discussing today, platform as a service deployments, basically eliminates the operations engineers from the picture, leaving just the concerns of the developers. And I'm going to be talking today about how to achieve those goals for all of the languages or all of the stacks that you would encounter in typical modern web development, because the approach to each stack might be somewhat different in a lot of cases, but Platform.sh unifies that. So to start, okay, pay attention, we're really getting started now, okay? We've got a very important deployment pipeline that I'd like you to study for a second before we get into it. Study it very carefully, please. Every step is important. Okay, got it? Now compare that to this one, all right? This one's even better because it's got more boxes. And keep that in mind while you look at some of the tools that I want to talk about. Wait, that's the wrong one. This one's even better. Okay, this is the one that I really want you to take a good look at every step, every tool involved in DevOps. Because these are actually just pictures I downloaded from the internet, as you can probably tell, just to demonstrate that nobody ever said this is going to be easy. There are lots of steps, lots of concerns, lots of workflow, lots of tools that are involved in deploying web applications. And it can be overwhelming sometimes, which is, again, why we're proud to present Platform.sh's solution to this. And I want to call out at this point one of my marketing teammates, Marina, for in particular this slide. She hadn't realized that I downloaded it from the internet, and she recreated it to look much nicer than the original, which must have taken a long time. So thank you, Marina. That was really sweet. To unify all of the languages and the way that you approach them as an application developer while eliminating DevOps, it has to start with actually going into detail about some of the idiosyncrasies and particularities about each of those languages. And in fact, you have to rest on some of the tooling that those languages come with in each specific case, particularly the application level package managers that those languages have. So we can't achieve a unified DevOps workflow if we don't take each language's needs into consideration, and those needs usually come best served from tools such as Maven or Gradle if you're launching Java applications, or NPM or Yarn for Node.js. Of course, PHP has Composer. So what I'm going to show you in terms of unifying the development workflows for each of these stacks and pipelines, it's really important to understand that recognizing which language and stack you're dealing with early in the pipeline and making decisions about how to process it is super important, and that these tools built into the stack can make a huge difference in making sure that your application gets built the right way at the right time. So I'm going to show you how that works in a bit. Another differentiator between the languages, which has to be considered when you want to unify the DevOps workflow, is what kind of language is it? Is it a compiled language, an interpreted language, a bytecode language? And I'm sure all of you are familiar with examples of all of those, but you're also then familiar with the fact that the process of preparing code that you've written in, say, a Java application for deployment is much different than the code that you've got in a Ruby application. And that's very humorously documented in this quite old XKCD, which I'm sure you've all also seen, about how these developers are just goofing around in the next room while their code is compiling, because compiling is actually part of the DevOps workflow and it belongs there. But where it happens and how it happens, that is a choice that Platform.sh has an opinion on. Another differentiating factor in the way that stacks and languages are deployed, beyond, say, their package manager and whether it's a compiled or an interpreted language, is also the deployment strategy itself. So some languages compile into a binary that actually has a web server inside of it. So Golang and Lisp, for example, they build into a binary which serves as its own web server. .NET is also like that. Then you have strategies like PHP FPM, which are processes that live in between the PHP code and the Nginx server. They're simply just to run PHP applications. Then you have yet a different strategy, like a monolithic application server, such as Tomcat, which can hold many different Java applications, and contrast that to also for Java Payera, which then is like an immutable microservice that you deploy as a single file. So all of these details about how you deploy your packaged code also have to be taken into consideration if you want a unified DevOps workflow. All right, let's get to that unified workflow. Again, coming back to developer responsibilities versus operations responsibilities, and where's the dividing line? Where's the boundary between those? So developer responsibilities include setting up your local development environment, using the package manager to get the code, writing the code, testing the code. But I have an asterisk near local dev. And the reason for that is that there can actually be crossover responsibilities there already, which is why we have DevOps. For example, if there are specific services like a PostgreSQL or an Elasticsearch or a MongoDB that are needed to make the application run, then either that developer will need a container image, like a Docker image maybe, or an online development server to be able to develop that application. And they can't necessarily provide those themselves, especially if they don't know or control the ultimate runtime environment. So they have to go to the operations team and get those before they're even enabled to do their development. Same with the package manager. You could say that's a developer responsibility to use a package manager to get all of the dependencies and the code from different repositories that go into building any typical web application. But if you put the responsibility into the developer's hands and you have lots of developers, inevitably some developer is going to use that package manager differently than the next developer, which can lead to inconsistencies. And finally, also testing. It's not enough to test on your laptop. It's not even enough to test an application on the dev server. Applications consist of code, infrastructure, and data. And usually testing is only truly possible if you have all three of those in a consistent state in place. And no developer in any significant situation has all of the infrastructure and all of the data that their web application is working on. So those are even responsibilities that cross over into the operations responsibilities. Operations responsibilities, on the other hand, include making sure that the build for every application is unified. And hopefully, at the end of this presentation, you'll see that these can be unified between stacks and languages as well as providing the infrastructure, maintaining the infrastructure, managing the data security, the data retention, data backups, providing security, network security, encryption, making sure that all of the software components are updated at the right time, all the time, providing the uptime guarantees and the monitoring for that, and reacting to situations when they arise. So these are the two different branches of responsibilities for developers versus operations. And in an opinionated, unified development workflow, the line of demarcation between those two stacks of responsibilities is git push. When I push the code as a developer that I've written to the upstream repository, that's the moment at which I've given over control to the operations side of things. And I expect everything else to happen after that point. This is an opinion, okay? But this is also the foundational opinion behind the GitOps movement. And Platform.sh was an early adopter of GitOps, coming up with that idea as early as 2012. So let's extend that a little bit more. The developer responsibilities on the left have stayed the same, but I've changed the operations responsibilities to indicate that some of those responsibilities, especially building the application, package manager, even some of the infrastructure considerations, are in fact highly dependent on what language and stack is being developed on. Whether it's a Node.js or a Python app makes a huge difference in how it's deployed and how it's monitored and how it's scaled. So for the developer, it's nice if they can get pushed to a remote, and after that, everything else happens, then they don't really have to worry about those different operational responsibilities. But the operations team does, or the operations tool chain. To extend that just a bit further, then after the code has been processed properly, depending on what language and what stack it's in, then there also has to be the orchestration of the runtime environments. And that often includes a lot of services, some of them are with persistent data, some of them with not, that are necessary for running modern web applications. And I'm going to talk about some databases like PostgreSQL or MySQL. I'm going to talk about some indexers like Elasticsearch, but there are also message queues like RabbitMQ, and also the omnipresent conundrum or problem of storage. So storage, making persistent storage available to your application is can be difficult. There are now very good tools for doing this, but there's some detail in there that is always interesting to explore. So I'm going to talk a little bit about how Platform.sh manages storage, and then at the end versus how you would manage that type of storage with Kubernetes. So let's get into examples. Everything becomes clear with examples. Let's talk about Lisp, a good old language that probably not many of you use to write actual applications, but maybe some of you used to learn programming with. But it's in fact quite popular with Platform.sh, and we actually have some applications that we use that are written in Lisp. So Lisp has a package manager that's called ASDF, like the first 4 keys on the keyboard where your left hand sits, typically. So you could accidentally type the name of that package manager. Lisp also compiles into its own web server called Hunch and Toot, which is the best word you're going to hear in this webinar. So I'm going to say it again, Hunch and Toot, because it's just wonderful. I think everybody should have a Hunch and Toot web server, formerly known as TBNL, which was a pretty lame name in comparison to Hunch and Toot. So for example, to run your code, all you have to do is type ASDF make and start the resultant web server, and then expose your environmental variables, and that's how you run a Lisp application. Sorry, bumped my microphone. How do you do that on Platform.sh? It sounds potentially complicated. You have to have ASDF, you have to compile, you have to start the server, expose the environmental variables, and take requests to it. This is how you do it in a typical platform app YAML file, which is the type of file that is required for Platform.sh to run a specific application. And this is a file that you put right alongside your Lisp code before you git push it to Platform.sh, which is where the developer tosses it over the fence to the operations. And in this case, Platform.sh would be the operations. So let's look at the code. You give it a name. We called it app. In this example, we could have called it Hunch and Toot. No. You give it a type, Lisp 1.5, and that then will determine how it's compiled with the Lisp 1.5 compiler. And then we give the web server some commands, like how you start the web example, or start the web server with the command example, which is the binary that contains the Hunch and Toot server. And then some locations, which are web server paths. So the root path then passes through to the example binary, and that's it. Also some persistent disk space, which you may or may not use, for example, for uploaded files. And that is all it takes to run Lisp on Platform.sh. Let's compare that to Java. For Java, you typically would use Maven or maybe Gradle to compile and package your code. You put the description for all of that in a POM XML file that gets compiled to bytecode. Other languages can also compile to bytecode, and that bytecode can be run in a number of containers. And there's a lot of richness around there that anybody from the Java world is familiar with. Then you choose an application container like Tomcat or Payara. You might put your package.war or jar into that and run it. And there are different ways of doing that that you can describe in the POM XML. Then you start that web server and expose the environmental variables. How do we do all of that complicated stuff for Java on Platform.sh? This is it. I see 7 lines of code, only one long command and a short little command. So first of all, you specify your Java runtime. Here we've got the Java 8 specified, but you could specify, I think, up to Java 14 is now available, if I'm not mistaken. Again, persistent disk for the runtime application. And then here we have something different. We have a hooks directive with a build. And this tells us specifically how we want to build the Java code. So the idea is that we commit the Java code and the POM XML and the platform app YAML file that you're looking at now into Git and push that to Platform.sh. And then when the build phase is being run, which is building the code, it'll run maven clean package Payara micro bundle, which will then result in a single file that has the application and the Payara microservice runtime ready to be started and take requests. And then the web command to start that is the Java jar XMX 512 and the rest of that with the port coming in from the environment. And that's essentially how easy it is to start a Java application on Platform.sh. Let's look at something more exotic. Let's look at Elixir. So in order to run an Elixir application, in general, you need a mix.xs file in your repository. And on Platform, the system will automatically download your dependencies in your deps section, your dependencies section, because it's using the package management tool that is specific to Elixir. Then your mixx file should be at the root. When it gets committed, then it will do deps get, deps compile, and then compile on your application to build the binary. And the binary then is capable of running the application. And here is the platform.app YAML file needed to actually do all of that. So again, specify the type, Elixir 1.9, specify the starting command for the server and the locations, and Elixir needs a specific environmental variable called mixenv. Set that to prod because that behaves differently than, I presume, dev. I'm not an Elixir developer, so I can't tell you specifically. And then that's it. You're ready to go. .NET, same thing. Web commands, .NET platform ASP.NET Core DLL, which is something that we've provided. And then to build, there at the bottom at line 12, there you see the one command .NET publish, which is configured to compile and publish the .NET code that it finds into its own .NET server. There you go. Just very briefly on Node.js, because that's very popular. Couple ways of running Node.js. This is maybe in the simplest form. You could run a Node.js server just with that. Just start the index.js file that would be in your code base. Typically, you're going to want more control over the Node version and some of the other environmental aspects. Node can be very, very finicky about versions. NPM isn't always going to be happy with every version of Node that you throw at it. And that can be hard for Node developers to manage. So you might want to use NVM to specify your Node version. That's a few more lines of code, but this shows how to install, for example, Node 9.5.0. All right. Or was that NVM 9.5.0? All right, well, you'll have to ask me afterwards for clarification on that. Good. So that was just a quick run through of how Platform.sh unifies the deployment and the coding of applications from different languages. How does that work with the services? So we offer a number of services from our services library, including Headless Chrome, Elasticsearch, InfluxDB, Kafka, MariaDB, and that whole list there, as well as several versions of each. So let's look at some examples. So typically, to run PostgreSQL, you've got to have a container image, you need to set up persistent storage, you need to set up how you're going to snapshot and restore the data in that persistent storage, and then you need to manage the routing between the app and the database. The database needs to be behind a firewall, but the application needs to be able to access it. So it can't be public on the internet, but the application needs to talk to it. And you need to set up monitoring. These are typical concerns of setting up a database for running a web application. So on Platform.sh, again, just a couple lines of code. In Platform Services YAML, you add 3 lines. So you see those at the top there. And then you need what's called a relationship in your Platform app YAML file. Those are the bottom 2 lines. What the top 3 lines do are actually provision the service. With just those 3 lines, you get a Postgres database that has a fairly small disk. In this example, only 256 megabytes. You probably want more disk space than that for your database. You can boost that number. What the bottom 2 lines do, the relationship, is provide the connection between the application, because that's in Platform app YAML, and the database. Okay, so that's not just the networking and routing between the application and the database, which is obviously important. And Platform.sh will give you IP address level security so that the database is able to accept incoming database requests from a specific container, but from nowhere else. It also gives you the environmental variables needed by your application to connect to that database. So of course, there's an authentication layer in the database, and your application needs to use that authentication layer to do requests against it. And to get the information on that authentication, on those authentication details, I'm thinking the user and the password typically, then the application gets those from the environment and the environmental variables that are provided by Platform.sh based on this relationship being there. So you ask for the relationship called Postgres database, and it will give you exactly the environmental variables and details needed to authenticate against the database. The reason that's really cool is that one of the features that Platform.sh is famous for is, in fact, every branch that you make in your code base results in a new environment that's an exact copy of your application with all of the containers and all of the code and all of the data. Meaning if you have an application with a database, a Postgres database, and it's got data in it, and you make a new branch, then you get a copy of that Postgres database, which ostensibly would have different credentials, or at least it's a different database. And if your application is going to then connect to that, it has to get the specifics about the host name and the credentials, again, from the environment, and those can change. So every time you copy or clone your application by creating Git branches, then Platform does the work of setting up new routing, new credentials. In fact, they don't change, but they could, and feeding those into the application as environmental variables so that they can be read out and used, and the developer doesn't have to worry about them changing, which is the nice feature. So I'm going to try something, and Catherine or Jonas or Kieran or somebody watching, if you can't see when I click through to this link because I'm failing at using Google Sheets presentation, let me know. But I'm going to turn to a couple of tutorials that I found on the internet that seem representative of how people would run PostgreSQL on Kubernetes. Just as comparison point to what I just showed you. Okay, so I'm just going to scroll through this and read some of the headlines. And honestly, Kubernetes is awesome. This is not a slam against Kubernetes. Kubernetes is brilliant technology that is making life wonderful for a lot of people. And I think it's really fun to play with. So even though I'm going to show you a lot of steps that it takes here, this is not a slam on Kubernetes, but it is a message that if you don't want to take on this responsibility and complexity, then there's an alternative, and that's Platform.sh. So you start by creating a storage class for Postgres, and that looks like this with some Kubernetes commands here. Okay. Then you have to deploy PostgreSQL through a Helm chart. And if you don't know what a Helm chart is, don't worry. That's like a package manager for Kubernetes. And the Helm chart can specify the Docker containers and the infrastructure and a lot of other things that you need. In this case, it would get the stable Postgres. So you'd end up with a PostgreSQL container. And then you tell it to set the persistent storage class based on what you did up here. You see the CStore SC YAML that remains consistent, and you give it in as a parameter. And then there's some output. And then you set up some Kubernetes pods, which are groups of containers. And you set up Kubernetes persistent storage with these two commands. And then you initiate the databases. And there's some testing that they do here for validation, which you can go through or not. And note that some of the things that they didn't mention in all of those steps are snapshotting the data, restoring the data, monitoring Postgres, and scaling it, all of that. Now, Kubernetes handles some of that. And in fact, some of the values the benefits that you get from Kubernetes are in, for example, auto scalability, keeping things alive and stuff like that. Like I said, not a slam on Kubernetes, but you get almost the same things on Platform.sh, plus the ability to clone the entire application, running application, into a new branch instantaneously, which Kubernetes does not offer you, with far fewer steps. All right, so let's look at the second tutorial. I mean, this is by a company called Portworx, and they're actually plugging their own technology for the storage layer. But it's once again representative that that tutorial was absolutely minimal. They again create a storage class in PVC. We saw those same commands before, and these are things that you would do obviously after installing your Kubernetes command line, or setting up a Kubernetes installation on a cloud and SSHing in there. Then to deploy Postgres on EKS, then they're having you create something based on something from GitHub. So it's a little opaque what that is and where that's coming from. So you'd have to look into that. And then again, they're getting the pods. And then they are going in a little bit here to inspecting the Portworx volume, which is their persistent storage. And they're doing something cool here, which is not exactly how we do it on Platform.sh, and maybe a differentiator that Kubernetes has that's interesting about failing over between SQL Postgres instances. And then they're benchmarking it. And yeah, I mean, it's a fairly involved tutorial. So after looking at Postgres, let's take a look at Elasticsearch. The steps are exactly the same. You need a container image, you need persistent storage, you need to think about how to snapshot and restore the data, and how the routing between apps and database is done, as well as monitoring. And in Platform.sh, to achieve all of those things, you need exactly, what do I see here, 5 lines of code. 3 of them are to provision Elasticsearch with some persistent storage, and that's the first 3 lines, and those go into Platform Services YAML. And then there are 2 lines that go into Platform App YAML that specify, again, that relationship between your app and Elasticsearch, where that will take care of any authentication credentials that are needed to authenticate against the Elasticsearch image, and all of the network routing, host name, IP address, everything. And Volkan, this is a place where I can actually speak to the difference between Heroku and Platform.sh. On Platform.sh, all of the services that you can launch this way come from this catalog here that I showed you already. These are the ones that are available, and anything else in terms of backend services that you might need, we can't offer you. You could put them someplace else and speak to them somewhere else, but you're not able to host them here. For example, there's no Oracle database on this list. If you needed an Oracle database, then we're not able to host that for you because we don't have a container in our container catalog. Now, that is a limitation. It means your application needs to be able to run with these backend services, which is in fact, a lot of applications are served by these. On Heroku, there's a concept of service providers. So it could be that you can run an Oracle database on Heroku, but it would be hosted someplace else. So there's an integration between Heroku and the actual provider of that Oracle database. We don't have that concept, and we specifically avoided that concept because the functionality where when you clone your running application by creating a new Git branch, and you get an exact byte-by-byte copy of the entire application, including all of the services and all of the data in 20 to 30 seconds, that feature, which is one of our killer features, depends on us managing all of the services and all of the data. That's how we're able to do that for you. So we made the trade-off and compromise of, and also I might add, I mean, look at the simplicity here on the screen right now of launching an Elasticsearch and making it available for your application. To get that level of simplicity and to provide the cloning on demand capabilities, where you get a running branch every time you have a new merge request or pull request, those depend on us running the containers and having a limited container catalog. So that's the reason and rationale behind that. So I'm not going to actually go through the tutorial that I got from Elastic on running Elasticsearch on Kubernetes. We can send it out in the post webinar communications, and you can read it on your own. It's very similar to the Postgres tutorial, so there won't be any surprises. It's several times longer and more complicated than this, okay, which is Platform.sh. But it's great technology, and again, I'm not slamming Kubernetes. I'm just pointing out that if you want to reduce complexity and move risk and complexity outside of your organization, then Platform.sh is a great example of how you can do that. Right, so let's wrap up a little bit around the benefits of the unified build and deploy with Platform.sh. It makes it so that your coders, they only have to code. They're not concerned with DevOps. They're not concerned with a lot of setup around services. You can see on our demos site or our documentation site or our community sites more information about how we allow local development to happen without even having to set up Docker or Docker containers. You can simply tether to the environment in the cloud and use the persistent data there. Another benefit is that everyone on your team will build consistently. So if you're on the same project, then you'll all use the same build package manager and build files. It's like Composer version and Composer lock, Composer JSON, or the same NPM version and Node version with the same package JSON file. So everybody builds consistently. And in fact, there's even consistency between teams because everybody knows that on Platform.sh, the way to do it is to set up your package manager file and then just git push to Platform.sh and your code gets built consistently. Services get set up quickly, 4 lines of config in most cases. And the definition of those services gets put right next to your application code. So you're committing both infrastructure definition and application code to the same Git repository, meaning you can version your infrastructure, roll back your infrastructure if you need to. So if I deploy and something's gone crazy wrong, and I've updated Elasticsearch and changed my code, but I don't know which one's causing the problem, I can simply roll it back. I roll back the code and the infrastructure upgrade in one operation. You use git push as the unified deployment method. This means that if I want to serve on multiple teams and they're all using Platform.sh, then I always know what I need to do to deploy. It's the same deployment mechanism, the same deployment paradigm, whether it's the .NET team or the Java team or the Lisp team, which I'm sure everybody's got. And again, you get cross-team common methodology and vocabulary. The Django team will probably roll their eyes and zone out if you start talking to them about the POM XML file. But if you talk to them about how you're using git push to the remote to deploy and the package manager is taking over, then that'll be familiar to them because they'll be doing the same, but in Django. So lots of consistency across your teams. Finally, I should point out, when you start a project on Platform.sh, there's the chance that you get to select a template where all of this is done for you for various applications and stacks. And I encourage you to go look at that. There's also a GitHub repository that I should have a link to, but I don't here at github.com/platformsh-templates. And you can look at all of the code for the templates that you see here and many more. There are close to 70 different templates that cover all of the stacks and all of the languages and all of the services that we offer. And not only are those useful starting points for any given project, if you're going to, say, do a Django 3 project or a Go project or a Tomcat EE project, those are helpful starting points, but they're also good for studying to see how we set things up with best practices in mind, so that if you just want to start your own project, you can learn from those examples. Good, that was basically it. But before I say goodbye, I want to call out that we are starting a new sub-series of our webinar all about the concept of fleet ops. So what is fleet ops? It's like GitOps, which I already mentioned, where you unify the deployment and infrastructure provisioning for your entire team around the concept of Git push. Fleet ops is how you extend that concept to not just apply to one site, but to apply to dozens or hundreds or even thousands of sites, because the problems that emerge when you have that many websites are in fact different, if not just amplifications of the problems that you're solving when you have one or a few sites. And Platform.sh believes that we have a unique view and set of tools on solving those problems. So if you have dozens or hundreds or thousands of sites that you're managing and you want to check that out, then look at our webinars, sign up. The first one is going to be by myself about how to manage hundreds or thousands of websites with fleet ops. No, that's not the one I'm doing. I'm doing number 2, Fleet Ops, your checklist for running thousands of websites. And then the third one, how the University of Missouri cost effectively migrated its fleet of web apps to the cloud. And with that, I conclude this webinar, but I'm going to go on and ask if there are any questions and take a look at the questions chat in case there are. Okay. No more questions have come in. All right, so I'm going to say thank you, everybody, and have a great day. Stay healthy, stay safe, and come back for our next webinar.